Well, welcome to Portsmouth, and we're honoured to have Eric, WA6HHQ, who's the co-founder of ELECRAFT, to come down and demonstrate the K4. It certainly had a lot of mention on the air. Even before it was born, it was being talked about last year, so it's nice to see that this K4 has almost, well, this one has been born. But I think ELECRAFT fans do talk about birth, don't they? The birth of this road in that race. Yeah. Anyway, we're honoured to have Eric here. Eric, let's hear a bit more about the K4.
Okay, well, this is the K4. It's Peter has mentioned that people were, and excuse me if I'm drinking tea and coffee, by the way. I flew in last night, got here at 6:45 this morning, and I managed to get 4 hours of sleep between 10 and 2 today. But I'm running on caffeine.
It's out of an MFJ mug, which
yeah, I know. I've got
more.
Well, they gave me a few other brands earlier, but we keep rotating the brands here. I'm an equal opportunity offender with this. So as long as it has caffeine in it, I'll be happy. So excuse me if I'm sipping once in a while. This one is finally out, and we've added a lot of neat new things to it, so I'll talk about that. Just to explain what's on the table here, and I'll go into more detail here. Of course, the K4 in the middle, built-in pan adapter and touchscreen display. And of course a lot of buttons, because we want to make sure it has the classic controls too, so you're not reliant on just a touch screen. I've also got an external monitor, which is HDMI. It plugs right in the back, and that basically can reproduce anything on the screen. It's not just a copy like a lot of radios do, where you just have a copy of the screen, maybe in lower res that you blow up, where you have all the extra buttons and information that may be redundant with what you're looking at here. What we do is we can take anything off this screen or anything else you want to put up there. It's a totally independent display. I've also got a tablet running here, and that's actually running remote control of the K3 over the, right now over a Wi-Fi network. There's Ethernet in the back of the K3, or K4. Just to explain what's happening here is I have the same user interface on this tablet that you see on the screen here. Yeah. It's the same pan adapter data, everything's streaming real time between it. One of the key features that sets the K4 apart is we have remote control built in out of the box. So when we built the K4, we basically built what's called a client-server architecture inside. We have a main multi-core Intel processor that runs our main supervisory code. Well, K-serve doesn't care how many versions of UI are talking to it at once. Here's another one running at the same time. So this one, I can go up here and I can change bands. So if I go here and hit the band button here, if I do that, and if I switch to, what are we on right now? We're on 7, so if I go to 14, there's 14, I just change the radio. And I can even tune the radio. If I go back out here, and I can do this on the same screen on the radio too, but if I touch the radio, you see the cursor jumping around there? I can also fine tune it by dragging my finger back and forth. If I actually turn this up here, you'll hear it being tuned. So I can change it there. So you can fine tune it also. If I were to give you a quick synopsis on what the K4 is, it's basically certainly a follow-on from a performance standpoint to the K3. We didn't want you to lose anything there. So a fully configured K4 has pretty much the same, what we call dynamic range, strong signal handling, which is very important over here, as the K3. We actually have several options that you can move up there in terms of adding more performance to it, the K4, K4D, K4HD, and I'll talk about those. One other, anyway, it's 160 through 6 meters standard. We do have an internal slot, though it's a teaser for you right now because the board for it isn't finished design yet. It won't be out till late next year. That will add, at a minimum, 2-band VHF, UHF capability, probably at 15 to 20 watts. We're going to try to push it as hard as we can. It's a question of how much heat we can get out of the box, but that will give you all mode on those bands. Locked to the reference of the radio, everything nice and stable for that. And you can use that for external stuff too if you want, in terms of microwave and things like that too. One of the key things about the K4 in terms of how we designed it compared to our competition, well, first of all, let me back up a little bit before I get into that. I didn't use the key word here. It's in the ads, of course, but we're a direct sampling SDR. That basically means it's sampling the RF, say, here at 14 megahertz, rather than down converting it to a lower IF. The K3, for instance, would convert it down to 8 megahertz for a roofing filter, or 8.2 megahertz, and then we'd convert it down to about 15 kilohertz to be directly sampled by a analog to digital converter for all the final DSP handling. Here we do it all up at the front end. The only thing in front of it, between it and the antenna, are preamplifiers and attenuators and bandpass filters that we can turn on and off for the band of interest, so you don't have to listen to all the junk out of band, possibly overloading you. So that gives you a lot of flexibility in terms of what we can do for processing. It also gives us the ability, without having to add a lot of extra hardware, to add the capability of a pan adapter in the box standard without adding an extra external box like we did with the P3. We in essence have one analog to digital converter, say for the band you're listening on, or two bands if you want. It has the ability of having two receivers. Each of our has two receivers coming in, even with a single analog to digital converter, because it's listening. It can listen actually to, if you conceivably wanted to, from 160 meters and 6 meters all the way through. But we're not going to do that. Usually that's sort of wasteful of the bandwidth on it. But you can listen to two bands at once, or two frequencies in the same band. We basically take that data stream, so it's sampling a broad stream, and then we go into a field programmable gate array. This is a digital chip that we can program. And that actually has 3 modules in it that basically are like down converters. They're digital down converters. They do it all digitally, and for everything is handled past them, it hands out 2 receiver streams and a pan adapter stream. So that's how we handle that in the radio. So the K4, a couple of things that set it apart. K4 is something unique to our approach to digital signal processing. We're not relying on the main processor in the radio doing all the heavy lifting in terms of processing and everything else. If you're familiar with some of the other radios out there, especially the ones that are based on the HDSDR open project on the internet, they're good radios. One thing I always tell people when they ask me to compare radios, I'll compare specs, but there's no really bad radios. I think we all have different ideas of which ones we like the best, but I'm sure like you, we all own a bunch of all the different brands out there, including my competitors. So, key thing we have though is that we've taken, rather than relying on a main processor which has to process large chunks of data and with some extra delay through the system to actually demodulate and filter and noise reduce and everything like that, we have a dedicated digital signal processor chip, similar to what we used in the K3. For those of you that are CW operators, we have very fast break-in, turnaround, transmit, receive time in the K3. In case of the K4, we don't sacrifice that. A lot of DSPs out there that we compete with, they're great for sideband use because you're not as critical on that. They might be for data where you want to turn around faster from transmit to receive. In the case of the K4, it's actually faster than the K3 on turnaround for QSK, fast CW. We went from up by a factor of 5 to 10 in speed on the digital signal processor. This is a fire-breathing Analog Devices DSP chip in their Shark family, and it runs almost half a gigahertz at speed, so it's flying in terms of that. And it's got dedicated processors for all the typical digital signal processing operations in there, so we can say go do that while we're doing something else over here inside of it. And that in turn spits that data out, actually either as audio, pan adapter data, and so on. It comes through there and goes to the processor to be routed to wherever it has to go to. In terms of other things we do though, is that I mentioned there's a touch screen, so you can touch the screen as I was doing here to tune. Of course you have also full button interface for most of the buttons you want to use on a regular basis. The idea is a lot of us want to have tactile feedback, and you get that as much from a screen. Some folks have more trouble punching the right spot in the screen, that we made our buttons big, the ones that are on here. So I can even hit it when I'm half tired like I am today. So, but the key thing here is that we have a classic feeling radio in the sense that you're not going to be alienated by just looking at a computer screen. And there's nothing wrong with computer operation, I do that too, and it can be controlled by a computer. But from the radio standalone, it feels like a classic radio in the front too. In some cases where you have touchscreens functions, they're usually like 90% of the time duplicated through a button somewhere else, so you can do it either place. A good example is I can hit the mode button here and pick which mode I want to use. It pops up at the bottom of the screen in big buttons, so I can go from CW over to sideband, go back to CW. Or if I went from there, if I tapped over here, I tapped on the CW icon, that brings it up too. So you can beat on the touch screen to bring it up, or you can hit the button to bring it up. For band buttons, we did something a little different. We have a band button down here. Let me turn this down. So that brings up all the big band buttons at the top, at the bottom of the screen there, nice and large. They're band stacking registers, which we did not have in the K3, so you've got that capability where you can save multiple frequencies in the band that you were using recently. And that's built in also. We did that here instead of having them all out here, so we want to make the buttons array too large, or spread out the radio and make it larger too. We tried to keep the radio size similar to a K3. It's about, using US terms, about an inch to inch and a half wider here, 3/4 of an inch higher in size. The weight actually is quite light. It's in the 12-pound range US, so that's less than, what, 5 kilos or 5.5 kilos, I think, right? The other key thing I mentioned is the remote is built in for it, which is a great flexibility over Ethernet. You can do the full remote as I'm doing over this tablet. So you've got the ability to have either software application control us and display the same data, or, well, actually, somebody asked about iOS and Android. Our goal is to have both of those. I'm an iOS user. I've got a lot of Android users. I have one iOS programmer who's probably going to work with us on the iOS application, we hope. We'll probably first come out with our own, probably a Windows 10 app, just because that's a wide base. You can run on a laptop, a PC, and so on. What I'm running here, as I mentioned, is running under Linux. That's the internal engine for us. By the way, we strip that down to the bare minimum, so we don't have a lot of hooks that you can get in from the outside, because we want to make sure that's not open to the outside world. You don't want to have your radio hacked, so we keep that. You can't, for those that are Linux or Unix people, we don't have a terminal interface SSH mode for it for you. That's turned off, so you can't go in there and root around inside the system and put your own stuff in there. I'm sure someone will figure out how to hack any radio eventually, but it's pretty well protected. But in terms of the overall buttons, we've got over here on this side, we've got all the buttons relative to the VFO, A to B, swapping VFOs, going split, copying from one VFO to another. All that's right above the VFO knob. In addition to direct frequency entry, tuning rate, and you can either tap on the screen here and change the tuning rate, which one you tap on. I'm at 1 hertz right there, or 10 hertz there, or I can tap on the button here, which is better. We made the buttons a little different than the K3, by the way. There's a physical switch underneath instead of what we had before, which was the back of the button was a conductive puck that contacted some traces on the circuit board that it would make the contact. That's worked out quite reliably, but we wanted to have a more positive feel to it. So these actually, if you play with it and turn the preamp on, that's probably a safe one to turn on and off. The clicking right now is the relay. Yeah. But if you're touching it, you actually feel a snappy click, and the buttons are not squishy at all. They're absolutely hard. Okay. Very reliable. There's actually a hard overlay, by the way. There's times we've been selling the, you have some handy talkies, the buttons wear off after a while, and the rubber buttons. I haven't had that happen on the K3s that we've been selling now since, gosh, over 12 years now, level. One key thing that's different also about the K4, K3 and prior products for noise reduction, we used a fairly common algorithm. It's called the LMS, or least mean square algorithm. It works well for reducing background noise to cut down fatigue when you're listening to signals, say on sideband. But it tends to sound like this, like there's a filter around you, right? I'm sure those of you that have used either on our radios or others know that sound. We wanted to get rid of that. We've gone to much higher performance. It requires more processing power, but we can do this in our DSP. We call spectral subtraction algorithm, where you actually convert it to a frequency domain, just like we're doing here to display the Morse code. And then we look at the signal, and if we want to look at, we actually push down all the other signals. That's the easiest way of saying we're getting them out. One side effect of that technology that other people have run into of using it is that if you're listening to a band that's got some moderate amount of static on it, and you're using this to reduce the background noise, it'll actually have sort of a musical sound in the background, almost like somebody's playing keyboards or a little calliope. It's not loud, but it's just sort of subtle. And we wanted to get rid of that, and we came up with a way of doing that. So it's a modified spectral subtraction algorithm. So this all, and that takes processing power. Having this fire-breathing DSP in there makes a big difference. So that helps us quite a bit. Top of the area was to make it so you could sit down and use it quickly also. So we made pretty much everything pretty obvious when you touch it. You'll find it even more so than the K3. Our menu structure is much shallower in the sense that you don't have to dig down to find something to change the setup parameter on the radio. It's also not on a single line like it was on the much smaller display in the K3. You've got a menu and you can scroll through and say, I want to do these transmit options, bang, bang, bang. And you can just do it if you want to set it up once. But generally operating the radio, it's all at this top level here, which is real nice. One of the things we also worked hard on the audio, so we've got even better audio both on transmit and receive than what we had on the prior radios. We can go up to about 4.8 kilohertz. That's useful mostly for the data mode people, though there are some ESSB people who would take advantage of that also. It does all mode, by the way, CW, sideband. We support internally data modes for RTTY, PSK31. CW can decode also. We should decode that on the screen if we want. I don't have that in this current radio with me. I ran out without the latest software. But nope, that goes really well, but I can narrow it down, and I can even go to shift here and shift it a little bit. Now, yes, you got rid of the interference. Yes, he's going to sound narrower, but you got rid of it. By the way, if you're ever adjusting shift and width here, you can just, like in the K3, push and hold it, and that renormalizes it back to standard default. So if you get lost, you can always recover. So basically 2 VFO displays here, dual S meters, pan adapter, by the way. I can go through here and adjust things like if the band's noisy tonight or not noisy. I can adjust the reference level, the base level for the pan adapter here. And a lot of times, if you look at it here, it's easier to pick out like the edge of a signal. And by the way, we have a mouse control built in. You can see a little cursor up there on the top of the screen. We'll eventually change that so it's a line going across the top rather than a cursor, but I can click on anything I want here. And I can fine tune it with the mouse, or I can drag it back and forth like that. So we give you multiple ways of interacting with the radio. You're not, if you find you don't want to use the touch to tune, you use the mouse to tune or use the knob to tune. It's up to you how to do it. Or direct frequency entry. So what's the difference between the three radios? K4, they all have the same base thing. Two radios, two receivers on the same band or different bands. In the case of the K4, you have to have one antenna feeding both of those receivers at the same time. So you're using a multi-band antenna if you're on different bands, or you're basically losing signal strength, obviously, if you have it optimized just for one antenna, if you're listening to two bands simultaneously. Inside the same band, of course, no problem, like if you're listening to the pile-up or other side of a conversation. The K4D adds a second analog to digital converter, which gives you the second antenna receive path, and that you now have two independent receivers with two independent sets of bandpass filters. I didn't mention if you want to listen on different bands, we turn off the bandpass filter on one antenna because you block the other one if you had that in the same path. But here you have a complete duplicate path, so you could have one on your transmit antenna and one on one of your other four receive antennas that if you have them all hooked up. So the K4D basically adds that second antenna to analog to digital converter path to the radio. Has its another set of bandpass, preamps, and attenuators in the front end, in front of it. Again, no crystal filters for that one. Both those radios give you approximately 130 dB of blocking dynamic range and up in the 100 dB plus range of IMD dynamic range. Blocking dynamic range at 130 dB is pretty big. That means somebody has to be more than 130 dB above your noise floor to start desensing your receiver, anywhere in the band. In the case of the K3, we pushed it another 10 dB higher for extreme cases like de-expeditions, running verticals on the beach with 2 or 3 people in the same band, all transmitting at 1.5 kilowatts within 100 meters of each other. That's a tough situation to survive. The K4 HD actually adds that capability. I'll get into that in a second. But for 99% of us, you never need to go there, even over here. So, although some folks want to have everything out, so of course we make that available for you too if you want to buy the whole package right away. One nice thing is you don't have to, because K4 to K4D to K4 HD is fully upgradable. So basically, you can start with the K4 if you want. It's simple. Let's get started with that. You got the same filtering, everything else in terms of receive filtering on it, as all the radios have. And you have the two receivers on the same antenna, so you can operate split or listen to two parts in the band anywhere you want, and so on. But K4D, as I mentioned, you can just upgrade with a couple of modules that plug in. There's no major surgery you're doing here. You're popping the covers off the top and bottom and basically plugging in and screwing in modules. I think in the case of the K4D, we add another analog to digital converter card, and I'll talk about those in a second. You have a digital compartment on this side, and then totally shielded from the analog compartment over here. When you pop this cover, you unscrew a couple of screws to flip up our main processor board, and then you plug in, take off a little retainer bracket, and plug in this board, screw it back, pop that guy back. You're not unplugging the processor, just moving it. Bolt it back down, put the cover on. And I think there's one board in the bottom you do. So very easy to upgrade. Going to the K4 HD, same thing. Now the K, you just plug in another module to it. The way the K4 HD gets that extra dynamic range is we go back to adding a couple extra roofing filters, but you don't need a whole flanks of 5 different filters to cover, wide frequencies down through narrow CW. We do basically roughly a narrow one, say under 1 kilohertz, somewhere in the 700, 800 hertz range, and another one up in the sideband range. What we do is we down convert, just like in the K3, down to 8 megahertz. And then we direct sample at the 8 megahertz output directly there. And we have way more dynamic range at the direct sampling analog to digital converter than we had in the K3's IO. Most people are buying the K4D from us. That's the most popular one right now in the States. Though people, I'd say about a third are buying the K4, the basic one, and then they plan to upgrade as they get comfortable with it. That's either from a financial standpoint where you have to negotiate with the other half of the house. This is our spousal theory of marketing. I actually coined that term. I want to trademark it someday. With the K3, you had so many little things you could add on. Yes. You had birthday presents forever, holidays and stuff.
Absolutely.
You're all set. I don't have quite so many on the K4, but I'm sure I'll come up with a few other ones I haven't thought of. But you'll have at least the upgrades from one version to the next. You'll have the transverter option when I get that out, the internal VHF, UHF option, auto tuner, of course. And after that's external to it, probably. Or have you gone through the city and had intermod come through when you're listening? That's what we call a third order IMD is how that's tested. That's when multiple signals, we usually test with just 2 at a very high level, off your frequency, get to a high enough level that they overload the front end of your radio. That becomes almost like a mixer. It actually starts creating all these sum and difference frequencies of those signals, And eventually one of those will end up on the frequency you're listening on, and you hear the pagers and all these other voices all coming through at the same time. On HF, third order IMD sounds more like just, hey, the band just got really noisy, or I'm hearing some random signals coming through, so it's all so quick you can't really pick it out, but it's covering up other signals. That's why it's important. That runs typically 100, the range that most radios have is somewhere between 100 and 108 dB above your noise floor on the radio, that it has to be above that in strength before it causes this problem. It overloads and it causes that distortion. If you're 98 to 108, those are all about the same from our perspective, because that's a huge dynamic range. Blocking, on the other hand, is a single signal. You ever been on a repeater, you pull up at a stop sign and your buddy's talking to you, and all of a sudden he gets close to you and your receiver goes dead? That's desense. That's a little different. That's one signal just overloading the front of your radio, and basically putting what we call your front end amplifiers or preamps in the radio into compression. So they basically lose sensitivity. And that's what blocking dynamic range is. So that's when you're listening to like a station, and all of a sudden there's, say you're on CW, and your buddy 2 doors down gets on, and he's on somewhere else in the band, 100 kilohertz away, but whenever he comes on, this guy goes away. That's blocking. It's different than having interference covering him up.
I think one thing that we mentioned, I asked about decoding on the screen. You can decode.
Yes, we can bring up a split window. I don't have it on this unit with me. On the K3, it was only on the pan adapter's external monitor. Here it'll be on the internal. So everything here is symmetrical. So it could be on the internal monitor, external monitor, one, the other, or both. And probably initially we'll say we'll bring it up on both, and then let you make the decision what you want to do, turn it off or something. But you could put a line up and say how much data you wanted to look at decoding. Of course, with data modes, there's new ones coming out almost every month now. Joe Taylor with the FT4, FT8 stuff that he's doing for very weak signal work. They're pretty innovative stuff. It's getting a little automated, but then that said, it's keeping the bands active too. When the bands are dead, you can get on and work DX that way too. So it's all fun. It's a hobby. So I don't judge it. Whatever people do on it. We have ESSB. We have sideband. Of course, the CW guys think everybody that's on sideband is crazy. The sideband guys think all the ESSB guys are crazy. Everybody thinks the FT8 guys are crazy, except the FT8 guys. Of course, most of the FT8 guys are sideband and CW guys that don't want to admit that they're on FT8, right? Myself included. So no, it's that's just the hobby. But yes, sir.
So how big is your staff compared to?
Just under 50. People in the company.
It's amazingly small.
Yeah, we keep it pretty reasonable. But the key difference there is this is more common in the Silicon Valley area where we are. We're in what we call Silicon Valley West, just over on the coast from the San Jose, San Francisco Bay Area. That's typically called Silicon Valley. In Northern California, we're the normal people in the state. That's what we claim. Those we get closer to the beach, we start talking like surfers. So I'll talk about gnarly radios and things like that. But basically. We have subcontractors that will do, for instance, surface mount soldering assembly of our circuit boards. We have purchasing outfits. Actually, it's a small company over in Silicon Valley that specializes just in purchasing all the components for our circuit boards used in our K-line radios, including the K4. They then supply those kitted per manufacturing batch to our assembly house, which is located just down in Monterey, 30 minutes south of us on the Monterey Bay where we're located. Just north of Carmel, where Clint Eastwood was the mayor a few years ago. He actually was a pretty good mayor too, by the way. They build it all there and actually bring it up to us. They don't have to ship it, they actually drive it up. One of their employees lives near us and they bring it up. So that keeps the head count down. I would be 150 to 200 people if I wasn't using subcontractors for those repetitive operations. And really they're better off for that because they have to go out and buy all the capital equipment for the surface mount assembly and wave solder and the inspection equipment. We even use, I don't know if you guys are familiar with the different chips we use for the digital chips. You have chips that have what you call PQFP or other ones that have zillions of little leads around the outside that you can barely see, or hand solder. They do that surface mount and reflow it with hot temperature. How to inspect that afterwards, they've got special high resolution digital cameras that actually can recognize a cold solder joint or a missing solder joint, things like that. And there's another package called a BGA, ball grid array. Think of a square piece of ceramic that has the chip inside, right? Instead of having leads coming out the edges where you solder it to the board, it's got all these little bumps on the bottom that are metallic little bumps. And on the board underneath, you have all these spots on the circuit board with solder paste on it. You put this placed on top of it, it'll squish, goes on top of it, and the whole thing gets heated up until the solder reflows. And these are actually more reliable than any other solder method we use. We were scared to death of them when we first looked at them. The assembly house has a full X-ray machine.
I suppose they would use X-rays for that.
Exactly. They use X-ray. They actually X-ray it to see if the connections are good when they're quality inspecting it. And plus, they have cameras that can look down on the side underneath the chip I mean, it's pretty amazing. So I don't want to buy all that stuff. Plus, it changes every 5 years. A couple things here.
Shut from cold. How long does it take for all this lot to boot up?
On the production units, it's going to run probably 10 seconds or less. It's not going to be 5 minutes or.
It's not like waiting my PC to boot
Doing
up.
updates.
No, it's not as slow as your PC, and it's not going to do Windows Update. If you've left it off for a while and Windows 10 wants to come in and update it when you first power it up. I have a lot of these little blue laptops behind me we use for different things at the trade shows, and they'll sit idle for several months at a time or a month at a time. And then we made the mistake once of powering them all up at the show, and we actually had internet hooked up at that show. They all started updating. We were shut down for an hour until they stopped doing that. So no, we don't do that. Again, everything here is pretty customized inside the radio too. A couple things, just a couple of highlight a few deals. I mentioned this monitor is fully independent, so it's based. I can put whatever I want on it. So we'll probably have some surprises for you down the road in terms of different things. We're also going to be looking for suggestions from people for what they'd like to see. We're not going to make it confusing and make it too flexible, but we'll be able to let you bring up set screens or maybe move the dividing line between different functions on the screen and stuff up and down. It's a performance upgrade. So what kind of performance upgrade can you put in here? What's really the heart of the system? In terms of this, interesting enough, it's the analog to digital converter chip. This is the thing it takes your 14 megahertz RF, say, and converts it in real time to a digital data stream. Everything after that, there's no tweakers of capacitor, trim caps, or anything. It's all done digitally inside. Lets us do all sorts of advanced signal processing to have you hear the signals better. Those are going to change. They're going to keep getting better. We've seen that over the last 5-10 years, because why you see more direct sampling radios out is because, in particular, Analogue Devices, which is probably a premier maker of analog to digital converters, both they natively, then they bought their biggest competitor, Linear Technology, which was one of the big ones out of Silicon Valley. This is a LTC 2208, I think it is, which is a 16-bit, 122.8 megahertz direct sampling chip. And that can basically cover everything up through 54 megahertz in real time, even all at once if you wanted to digest that. Well, those are going to get better, and they're going to get better both in terms of how fast they go, how many bits they have. More bits means more dynamic range. In other words, the ability to listen to strong signals when weak, listen to weak signals when strong signals are next door somewhere, not just from filtering but from overload, because you only have so much that you can handle, and then the analog to digital converter says uncle and says I can't handle this, and it has to turn in automatic gain control or something, right? And so you don't want that to happen. Now, we've done a pretty good job with this part, but previous parts weren't as many bits, and so you would find cases where you had to have more filtering in front and stuff. The other thing is linearity. How linear is it? In other words, if you have 1 volt change going in, does the digital stream represent that as exactly 1 volt change coming out of it? And how many if you want a straight line, ideally, as you compare input to output voltage, how much is that wavering back and forth as you go up? All analog to digital converters have imperfections. They're small, but they keep getting better. The manufacturing processes get better, both manual and how the chips are designed. The technology gets better they're working with. So we know we're going to have better parts in the next 5 to 7 years. All of my competition out there has, to my knowledge, has everything soldered onto their main board. We have a small, very small plug-in board that has the analog to digital converter, direct digital down converter, and this BGA-based gate array, and also a very high-speed processor in there to help process some of that data. One in the case of the K3D, two in the case of the K3, one in the case of the K3, two in the case of the K3D. And those are standard right now for us, but someday in the future, I won't say when, because I don't know when that part's coming. They haven't announced it yet, but other companies like Texas Instruments are coming out with new parts, which pushes Analog Devices to do better with their parts, and I'm sure somebody else will come out with some other one that surprises everybody. This gives us the ability, say 5 years in the future, I'm not picking the date absolutely here, we figure, hey, we can get another 10 dB of dynamic range just by having a better analog digital converter chip, plus it has better linearity, so less intermodulation issues too in terms of strong signal handling. That will improve it even more. And the goal here is to provide upgrade paths like that. So we left that back door open to improve the radio and give you a path. And another birthday present, to this. Keeps us in business. Keeps us in business, but it also keeps you.
It's just got white coils anymore.
Yeah, I know.
My Toro winder.
Make sure I'm not missing anything else here. By the way, like all of our radios, the transmit receive is pin diode switched. Yeah. So it's silent transmit receive. Even up to our 1500 watt amplifier, we're pin diode switched. That's something I'm really picky being a CW operator, among other things, since I was a kid. I hated hearing relays going click, 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 click. Even the read relays used in a lot of radios, you hear that after a while, so it makes a big difference there too. Probably more than anything else, we'll let you guys play with it here so we can come up and play with it. But let's answer questions first. Yes, sir.
One more question. We were talking about remote operation earlier. It's not just the control of the cat control, it includes audio and such like as well, doesn't it?
Yes. Oh, actually, thanks, because actually I forgot to talk about that in more detail. So what does remote operation consist of? Well, a lot of us have seen where you can have a computer controlling it remotely. That's what I'm doing here with this screen. I'm using the UI reproduced here, but this is going over Ethernet out the back of the radio to a router, which could be going over the internet. Doesn't have to be in the same room. And the data stream you can see is full speed. You're not losing anything, and you can come play with this afterwards. This is just more to show you how well it worked this way. At Dayton, I actually had this running, talking to this radio, which had signals going to it, and another K4, because we can also have one K4 out of the box today, already controlling another one. So I can put this K4 into what we call client mode, or controller mode. To control this one is going to act as my server, and it just basically connects the same way this one did over the network and says, hey, I'm another user interface. I'm not using the radio part of me right now, it says. I'm just using the user interface part with the display and buttons and microphone and everything else in it, but not the RF section. And now I'm controlling a radio halfway across the world. And that works right now. At Dayton, I actually had, at the Dayton Ham Radio Convention, we had, I think, 3 K4s there. Wayne had one at his stand to show people. I had 2 at mine, plus this. And the 2 were about a meter apart from each other. The one in the middle was the one that had signals going to it. So it had an RF cable coming in, you could tune the signals and see them on the pan adapter and everything. Then I had this other K4 off to the right. It just happened to have the same signals on it. Why? Well, besides we're using the same signal playback system here for RF, but also, important thing is it was coming from the first radio, and it was remote controlling that radio at the same time. At one point, we had one guy controlling the middle radio, tuning signals, and all of a sudden his cursor started going the other direction. And he didn't realize it was the guy over on the right turning the VFO the other direction. And they didn't know he was remote controlling radio. He thought that was a real radio with an antenna hooked up to it. So that's how good it runs. You don't see any lag or anything. If you have an extremely slow internet connection, you might see a little lag. But most of us have something that's reasonably fast. Doesn't have to be lightning fast. Doesn't have to be optical. Cable is great if you have that, or DSL even. I take even 4G over the phone systems and do it, and it works quite well too. Because you think about it, those things have multi-megabit, even the 4G stuff, multi-megabit capability of streaming data. We're using the highest part of this is about 0.5 megabit per second for the pan adapter data. Audio and all the other control stuff's down way below that in terms of throughput. So the idea is to give it audio, control of everything out of the box. You don't have to hook up a bunch of extra boxes outside to do the remote control functionality to add all that, or add some complicated software externally to do it. There's some good software solutions, some good hardware solutions out there. And this will work with those, by the way. It has all the legacy I/O that the K3S had in it. So, in addition to the Ethernet. We also have USB-A. You can plug into the front. I happen to have my mouse plugged in with a dongle here. You can plug in a keyboard if you want. There's 2 more in the back. You could plug in a flash drive and save your setup. Say your buddy has a different way of having the radio set up. You both like to operate contests on the same contest, and you're switching back and forth. Well, how do you keep fighting over how the radio is set up? You can save one on a flash drive here, one here, plug it in, or you can have both on one and just switch. We could switch the setups back and forth. So that's a nice feature too. Yes, sir.
Eric, when do you think they'll be available for Europe? You're going to get asked this.
Yeah, Europe's going to be a little bit later because I have to start shipping and go through CE certification at that point with shipping units. Actually, I can't take an engineering unit. It has to be a production-ready unit. It's probably going to be sometime near the end of the first quarter this next year, assuming I don't have any surprises ramping up. One of the challenges as we ramp up, we have a certain number of parts coming in early, then all of a sudden get a lot of orders and you're trying to catch up. That's a challenge. But secondarily, some vendors have a long delay time responding. The people that make the flat screen displays, the people that make some custom parts for it, like the keypads, things like that, that can be 8 to 12 weeks sometimes delay. If they have a hiccup, then that slows me down. So that's always the negative side of it. But I'd say in that second quarter time frame, realistically, of this next year for you guys. There may be some samples getting out to Waters and Stanton a little bit earlier here for you to show off to people and play with, but in terms of production shipping stuff. I'm not selling this one yet, sorry. That one stays with me.
I'm wondering how you're going to get out. That's what about getting home.
Yes, sir.
Is there an option to do diversity reception?
You absolutely correct. I missed that one. I'm sorry. This is the jet lag kicking in today. Yes. For those of you who don't know, diversity reception is using on the same frequency, same band, 2 different receive antennas at the same time with, in essence, 2 receivers. In order to do that, you have to have 2 receive antenna paths into the radio at the same time, going, again, to 2 A to D converters. That's the D in the K4D, K4 for diversity. It also adds the 2 antenna paths for different bands if you want, for optimized antennas that way. We already do this in the K3 already. K3S especially uses the same synthesizer, so it's phase locked between those two. So as you tune the band, you don't hear a whoosh, whoosh, whoosh sound. It's a little confusing because you have one in one ear, one in the other. The trick is you have 2 different antennas. They don't have to be monster antennas. You might have a 80 meter dipole and a 40 meter dipole. You're operating on 80 meters. The band is just opening up to the US. Maybe it's opening up to Hawaii, and that 1 out of 1,000 chance you're going to get that in 80 meters from here. And signals are just coming above the noise, right? Anybody working on 80 meters yet from here? I'm sure it's been done. Yep, back there. Probably bigger antennas though. But what'll happen is they'll fade up and down above the noise, and of course below the noise, and you'll lose the signal for a while, and they'll come back. When you have diversity, for those of you who know this, I'm speaking to the choir, but if you have diversity, if the 2 antennas you're using, even if they're not barn-beating, fire-breathing antennas, if they're located geographically different horizontally or different altitudes, they'll favor different arrival angles or directions for the signals. They'll tend, because the signals are constantly changing their arrival angle, depending on what the ionosphere is doing. One antenna will be better than the other at any one time. So when you have diversity, it may fade out of this one over here, but this ear over on the other side is hearing the other antenna, another receiver, and it's still there. And so you haven't lost that signal. So in contests or working a de-expedition or whatever, you're more likely to be able to hear what's going on both sides. And for our products with the K3, for instance, people using that in contests say that increases their rate of working people, which of course is everything in a contest, because they don't have to ask for repeats when somebody's signal gets covered or below the noise. So,
The
yes,
other
sir.
thing that's,
Anyway, the K4D adds that capability, and of course the HD has it also.
can you do noise reduction with it, where you mix the phase to get the
Oh,
noise
and
cancellation?
are you thinking in terms of nulling out an interference signal? I've been asked that about 10,000 times, and you might see that show up inside the software in the radio too. I won't guarantee it at first release. It's quite capable of doing that though. The question is, can you? This is where if you think about it, if you have most people use external phasing boxes to do this. Say if you can have a little sense antenna which picks up local noise to you, power line noise, or your neighbor's plasma TV, or other fun things that might interfere with your reception. And you want to, but rather than, it's hard, how do you notch that out so you can't hear it? Well, if you can have a second antenna, diversity again this time, coming in, and instead of listening to them in both ears, you feed them together into the same feed, and then you flip the polarity on that signal, it subtracts from it. Of course, it would cancel out if that was fully omnidirectional and exactly the same as your other antenna. But if it's set to be favoring the direction of where you're listening to, or you can adjust the delay between these two so it's not exactly 180 degrees, you're basically steering a notch directionally around your house. Sort of like the AM broadcast stations do when you see multiple towers and they switch patterns at night, north and south. And so, yes, you can use an external box with it out of the box with us right now to do that. But because we're in diversity mode, we'd probably have to put a mode where it goes into 1 speaker instead of 2 for diversity. But the ability to do it inside is something I want to do. So I'm not going to announce it at first ship because I want to get the radio out the door, but that's a great idea.